Hi, we're going to start our set of videos for Chapter 2 for our course today. And as you hopefully are already aware, the topic is frequency distributions. So when we're talking about frequency, we're talking about counting, really. When we want to know the frequency of something, we want to know how many or how often. So really, this whole chapter is just about ways of counting it within our data. So we are going to provide some form of table or graph that has the number of individuals located within each category. So in other words, if we were doing a survey about color, the categories, different colors, red, blue, green, pink, whatever, and how many individuals, count them. How many people said red was their favorite color? How many people said blue was their favorite color? And we can put that again into a table or into a graph. So what we'll end up starting with when we get going is tables, and then in the back half of this chapter we'll move into graphs. Before we can do any of that, however, we have to get some new notation. So in Chapter 1, we got some statistical notation for the first time. We got the symbol X for raw score for one variable, the symbol Y for raw score of a different variable, and sigma, that Greek S that looks kind of like an E, for summation, for adding up whatever it's attached to. So we're still going to have those symbols, really not so much the Y's, but X's and sigmas we'll continue to have. But there's a few additional things we're going to need. So the first new symbol for us is the capital letter N. And in a statistics course, whether a symbol is capitalized or not can make a big difference. So when I say capital N, make sure it's a capital N. N stands for the word number in this case. So capital N is telling us the number of scores in the population. So what's the total number of scores in the population? It's not telling us what the scores are or how many of each. It's just saying how many scores in total did I get. And because it's capitalized, we know that it's relative to counting the scores from a population. Lowercase n tells us the number of scores, the total number of scores, from a sample. So they both mean number of scores. Mathematically, it's interchangeable. 5 scores is 5 scores. But all it's telling us is, did it come from a population, which would make this a parameter, or did it come from a sample, which would make this a statistic? So, but mathematically they're interchangeable. They mean the same thing. So we need to know how many total scores were there from either my population or my sample. Next up for us, that's my best handwriting of an italic, lowercase f. F, of course, stands for frequency. There will be a capital F later in the course that means something completely different. So lowercase f. F for frequency. How many? How many reds? How many blues? How many of this major? How many of that major? So again, the N's just say how many answers, how many measurements do we have in total? And then frequency is sort of breaking it down. Okay, out of that total, how many are this answer? How many are that answer? Our response categories. 2 other symbols that we'll end up using today. One is a lowercase p. The meaning on that will shift a little bit way down the road, but right now it means proportion. P stands for proportion. So a proportion is telling us the total fraction of the data associated with a particular score. Now that is the text definition, basically, fraction, but of course we're not dealing in fractions, we're dealing in decimals. By fraction, it just means portion. Proportion. So what fraction, how much of the pie is associated with the answer red? How much of the pie is associated with the answer blue when we're asking for favorite colors? So this tells us what the actual raw counted at. 5 people said red, and the proportion of that is telling us, again, relative to the whole, how many there are. We'll do an example of that later, of many, and you'll see the difference. And the last thing, symbol that most of us already know, the symbol for percentage. Proportion and percentage are the same. Just percentage is a proportion multiplied by 100. So they're both telling us the same thing. What part of the whole is associated with each answer, with each category? They're just written in 2 different formats, written as a proportion or written as a percentage. So those are the new symbols that we'll end up using today. Now, the very first thing that we're going to build today is a frequency distribution table. And I'm going to need this space, so I'm going to get rid of that. So obviously abbreviating here, frequency distribution in a table form. So this is the idea of doing our job that we just described, but putting it into the table into the table format. So the first thing that we're going to need to do this is some raw data, some raw scores to work with. So let me get some scores written in here for us. Okay, so I had to line break there to make sure it all fits. So this is our set of data. This is our collection of raw scores. Whatever we measured doesn't matter. So this is our collection of X's, if you will, our raw scores. So we want to put this into a frequency distribution table. At its most fundamental, a frequency distribution table has two columns. It has one column that indicates the score categories. What are the possible X values? And the other category, of course, is going to represent the frequency and how many of them are there. So step one in building a frequency distribution table is to build a blank table. You've got to get your workspace set up. So we would need two columns here so far. We'll add columns as we go. And a column for the categories, the possible categories, and the column for those frequencies. So now what we do is we look into our raw data and we look for the highest value score we can find. We always start with the highest value. And as we look, we can see the highest value score we have is a 5. So we're going to put that at the top of the possible score columns. Now we're going to look back into our data again and say, well, what's the lowest score I have? And the lowest score in this set of data is a 1. So we're going to go from 5 down to 1, listing every possible category in between. Now is the frequency part. Now is the counting. So the first question here is, well, how many 5s are there in my data? So we go over to the data and we go, well, there's 1. That's it. There's only 1 5. So the frequency of 5s is a 1. Now we go to the 4s and count the 4s. How many 4s are there? Let's see, 1, 2, 3 is what I see in there. So our frequency of 4s is a 3. How many scores of a 3 do we have? So again, we go through our data, carefully check it, make sure you don't miss or count anything twice. And we're going to discover that there are 5 scores of a 3 in there. How many 2s do we have? Again, we go through the data, we take our count. We're going to see we have 3 2s and 2 1s. At its core, at its most fundamental, that is a frequency distribution table done. Now, it doesn't tell us a whole lot of information, which is why we're going to add to this table in just a little bit. But the first thing we do before we move on is we want to sort of check and make sure that we've done things correctly. So one of the things we want to check here is we want to see what the total number of scores is. We're going to call this a population. I could have called it a sample and used a lowercase n. Again, mathematically it doesn't matter, but let's pretend it's a population. So this says, how many scores are there? Well, what most students want to do is to say, there's a 5 and a 4 and a 3 and a 2 and a 1. 1, 2, 3, 4, 5 scores. Well, the problem is these are only the score categories. There's 1 5, but there's 3 4s. So there's a 5, but then there's 4 and 4 and 4. So already I'm up to 4 scores, and then I've got 5 3s to go. So now I'm up to 8 scores, and I've got 3 more 2s to go. So what we need is a simpler way of doing this. And the way we do that is simply to get the summation of the frequencies. So if we go to this frequency, 1 plus 3 plus 5 plus 3 plus 2. If we add all those numbers up together, we will get the value for the number of scores in the whole set. So go ahead and do that, and let's see what you get. 14 is what I've got. So now we know that there are 14 scores there based on how we figured that out. Again, just adding this up. Now what we want to do is double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Those two numbers need to match. One of the simplest things to check to catch errors, and a lot of students won't do it because they think, I don't need to mess with it. But they accidentally said there were 4 3s instead of 5, or they accidentally said there were 4 2s instead of 3. All you have to do is miscount one of the scores one time, and everything else we're going to do is going to be wrong. So we always, one of the things you'll hear me say a lot in these videos is if you can double check your work, you should double check your work. And so this is one of the ways we can double check some work in here to say, well, do I have the correct number of scores? So in the next little bit of video, we're going to look for some other things we can do with this simple table, and then we'll be adding some more onto it as we go.